How are you? Welcome, mathematicians. Today, I want to take through the topic on multiplication of matrices, and I want us to deal with scalar multiplication. This is whereby a single number called a scalar, is used to multiply each element within a matrix. So this is a scalar or a factor. So we are going to use this 5 to multiply this matrix here. Every element, each element. So let's begin. I already started here. 5, you multiply by 2. And then 5 times 3. Then 5 times 5. 5 times 5. So 5 times 2, we get 10. Matrix. You can derive a common factor. For example, this one, the other way around, you can come and derive a common factor. So you can write it like what is the common factor, the number that you can divide by this one, each element here. So the common factor is 5, already 5. If you derive the common factor from this, you're gonna be back to this. In multiplication of matrices, the condition is this: the number of columns in the first matrix must be equal to the number of rows in the second matrix. So, for example, this one has 1, 2, 3. It has 3 columns. And the second matrix has 1, 2, 3. It has 3 rows. So, we are going to post multiply the first matrix with the second matrix, or pre-multiply the second matrix with the first matrix. So let's go about. So first of all, we are going to deal with the rows of the first matrix. We are going to multiply it with the corresponding elements of the column of the second matrix. So 5 times 8. 5 times 8. Then you add plus 4 times 5 plus
6 times 9.
Then let's move to the second row. 3 times 8 plus corresponding element 5 plus 1 times 9. Well, we get 5 times 8. We're going to get 40. 40 plus 4 times 5, 20. Plus 6 times 9, 54. Then 3 times 8, we are going to get 24. Plus 10 plus 9. So this is 40 plus 20 plus 54. Suppose we have 2, 4, 6, 5, 3, 4. How many rows does it have? It has, like, this one has 3 columns. So the second matrix has to have 3 rows. So let's take an example of 4, 3 rows, 5, 6, we want it to have two columns. 6, 7, 8. How many rows? 1, 2. 2 rows. 1, 2, 3. 3 columns. So this matrix, since this one has 3 columns and this one has 3 rows, we are able to multiply it to get an answer. So let's go about. We're going to do like this. We shall multiply 2 times 4. 2 times 4 plus 4 times 5 plus 6 times 6. The rows first. So then we move to the second row. And we are still in this, using this 5 times 4 times 4 plus 3 times 5 plus 4 times 6. Wow. Let me, for space, because of space, let me route this. So we are going next. The next thing is 2 times the second column. 2 times 6 plus 4 times 7 plus 6 times 8. 5 times. We are moving to the next row. 5 times 6 plus 3 times 7 plus 4 times 8. So what is the answer? Allow me move to this space up here. So 4 times 4, we are going to get 8 plus 20 plus 6 times 6, 36. 5 times 4, it is 20. Plus 5 times 3 times 5, 15. Plus 4 times 6, 24. Then this one. 2 times 6, 12. Plus 4 times 7, we get 28. Plus 6 times 8, we get 48. 5 times 6, we get 30. Plus 3 times 7, 21. 4 times 8, plus 24. If you have a matrix A times B, it's not equal. It's not equal to B times A. The product that you'll get here is different from the product if you interchange. So in multiplication, you cannot interchange and get the same answer.